Example 2 of the Exponential Functions Lab, Part 2. In Part 1, we've had this function f of x equals negative e to the x plus 3 plus 10, and we determined how we would transform f of x equals e to the x to get this function. We found that there was a reflection across the x-axis, that there was a horizontal shift to the left 3, and that there was a vertical shift upwards 10, and then we graphed it. For Part 2, we want to determine some key information about this function, such as the domain, the range, if it's decreasing or increasing, if it has any x-intercepts, y-intercepts, and asymptotes. So we're going to look at the graph to determine the domain and the range. So our graph here, y equals e to the x, which is our basic transformed function, is in red here, and our function that we're trying to look at is in black here. So our domain is our x values, and we can see that our x values can be anything essentially. So our domain is negative infinity to positive infinity. Next, we'll look at our range. Our range in our original untransformed function, y equals e to the x, is from 0 to infinity. We've had a reflection over the x-axis, so we see that our range will be somewhat the opposite, and we've had a vertical shift upwards 10. So we see that on our black function here, that our range is from negative infinity, all the negative y values, all the way up to 10 here. This is 10 if you can't tell. So our range is from negative infinity to positive 10. Next, we'll look at it whether it's decreasing or increasing. We see that when we go left to right, that our function gets more and more negative, so it is decreasing. We'll look at our x and y intercepts. Looking at it graphically, we see that we have a x-intercept at negative 0.697, around there, and that we have a y-intercept at negative 10.086. So that's how we can look at it graphically. We can also solve for algebraically, which I will do for you. So if we want to solve for the x-intercept, starting with the x-intercept algebraically, our x-intercept happens when y is equal to 0. So our function is f of x equals negative e to the x plus 3 plus 10. So we're going to substitute y, which is f of x, as 0. So instead of f of x, we'll have 0. And we'll have negative e to the x plus 3 plus 10. So now we need to solve for x. So to do that, we're going to try and get x alone. So we're going to subtract 10 on both sides. So we'll have negative 10 is equal to negative e to the x plus 3. And then we're going to get rid of this negative on both sides by either multiplying each side by negative 1 or dividing by negative 1. And when we do that, each side will come out positive. And now we need to get this x plus 3 down from this exponent. And the way we'll do that is we'll take the natural log on both sides. And the reason we have to take the natural log is because the natural log has a base of e, and so in certain terms it'll cancel out. So we'll take the natural log on both sides. Natural log of 10 is equal to the natural log of e to the x plus 3. And remember, the natural log of e is actually, it just cancels out because the natural log has a base of e, and so essentially what this does is just cancels out and it brings down this exponent here. So we have ln of 10 is equal to x plus 3. And now all we need to do is subtract this 3 on both sides. So we have ln of 10 minus 3 is equal to x. And if you plug that into a calculator, you'll get the same result from what we had before, from where we had before and graphically, which was negative 0.697, around there. And so our x-intercept happens at negative 0.6970. So that's the point the x-intercept is at if you want to solve for it algebraically. We'll next solve algebraically for the y-intercept. So for the y-intercept, this is when x is equal to 0. So going back to our function, we have f of x is equal to negative e to the x plus 3 plus 10, and our x is going to be 0. So we have, and substituting y for f of x, we have y is equal to negative e, and when x is 0 here, it'll just be 3 up there, plus 10. And we notice that we can actually just put this directly into a calculator. And when we do, we get the same thing that was in our graph, which was about negative 10.06. So our y-intercept at 0, negative 10.086. Lastly, we'll look at asymptotes. An exponential function has no vertical asymptotes. So we'll look at whether it has any horizontal asymptotes, and we notice here that it does at 10, y equals 10. So we'll record that. So it has a horizontal asymptote at y equals 10.